Okay, let's get out the homework from yesterday. Looking at these problems I gave you, 16 I helped you with in class. 28 is very similar to the one that we did the last example from yesterday. Change either your cotangents to tangents or your tangents to cotangents. So let's look at 36 because I think it's the other one besides 45 that's super terrible. I mean, it's not super terrible, but it's the only other bad one, I think. And again, definitely I think the right side is the side that I would work on. And again, fractions, I hope you're starting to see that when you see fractions, you need to get a common denominator. So my common denominator is going to be sine of t times 1 plus cosine of t. And I feel like that maybe people just don't understand common denominators because it seems like the big struggle that people have been having is how do I get this next step? Show more work if you need to, right? If this side, if this denominator is supposed to become this, what am I missing? Well, I'm missing a sine of t, so that means I multiply the top by sine of t. So that becomes sine squared t. And then on this side, I have sine of t, so I got that part, but I don't have 1 plus cosine of t, so I need to multiply this by 1 plus cosine. I already did the bottom, so that's why I don't ever usually write the bottom in, but there's been lots of confusion. So now on the top of this, I have 1 plus cosine t times 1 plus cosine t. So I'm going to go ahead and FOIL that, and that's going to be 1 plus cosine t plus cosine t plus cosine squared t. And again, that just comes from FOILing that. Don't forget the middle term there. And then again, I'm going to kind of simplify this. I hope when you see sine squared plus cosine squared, you're thinking of 1. So I'm going to say that I get 1 plus 1 plus cosine t plus cosine t, and probably I don't need to write that step, but I already did, so. 1 plus 1 is 2. Cosine t plus cosine t is 2 cosine t. And I hope maybe you see where I'm going with this. I can factor a 2 out of that. So if I factor a 2 out of that, look what happens. I can now cancel this out. And I'm left with 2 over sine of t equals 2 cosecant t, which means I can pull that sign up, and that just becomes 2 cosecant t equals 2 cosecant t. That's a good proof. That's not super hard, but it's also making you do some algebra and put things together all at the same time. All right, let's look at 45. Just because I want you to see that this is possible to do. Right, I think that's 45. When I first started this, I tried to just get a common denominator, just like I did with the 36, because I saw fractions, and I thought, you know, that's the way that I need to do this. But I didn't really get anywhere. I got a big kind of mess, and nothing canceled out, and nothing went together. And so then I went to sines and cosines. And it does get a little messy here, and so you want to kind of keep track of all your denominators here. So step 1, let's go to sines and cosines. So I'm going to get sine of x over cosine of x over 1 minus cosine of x over sine of x plus cosine of x over sine of x over 1 minus sine of x over cosine of x. And actually, I'm going to be a slacker on this one, and just because it's so long, I'm going to not write the other side until I get to the end. But the good thing about writing the other side is you remember what you're supposed to get. And now I have all these fractions, so I think I need to get a common denominator on each bottom fraction there. And again, you got to understand fractions to do these problems. So on the top here, I have sine of x over cosine of x. On the bottom, this 1 is just going to become sine of x over sine of x. So it's going to be sine of x minus cosine of x all over sine of x. I don't know why I changed the blue here, but let's just go with it. Over here, I have cosine of x over sine of x. And on the bottom, I'm going to get cosine over cosine, right? That's just going to become cosine over cosine. So that becomes cosine of x minus sine of x all over cosine of x equals 1 plus secant x cosecant x. Just want to keep that in my sights here. Now that I have a fraction over a fraction in each one, I think we should see what we can do. Like multiply by the reciprocal. So that's going to stay sine of x over cosine of x. And then I'm going to flip the bottom over. So that's going to become times sine of x over sine of x minus cosine of x. Do the same thing with the other side. So that's cosine of x over sine of x times the reciprocal of the bottom, which is cosine of x over cosine of x minus sine of x. Been really nice if some stuff canceled here, but you can't break up addition subtraction in the bottom, which means that we can't cancel out. I left my denominators not multiplied out, again, in hopes that something would cancel, but I'm not sure if that's a good idea, but I'm going to just leave it for now. So on the top here, I get sine squared x over cosine of x times sine of x minus cosine of x plus cosine squared over sine of x times cosine of x minus sine of x. So on the top there, I see that sine squared and cosine squared, and I think, oh my gosh, maybe something's going to happen. But when I try to put my denominators together, think about what we need here, and there's a couple ways to think about it, but I need a cosine, I need a sine, right, for my denominator if I'm going to add these together with the common denominator. I need a cosine of x, I need a sine of x, and then look at the part that's in parentheses. I have sine x minus cosine x on this side, and I have cosine x minus sine x on this side. Those are almost the same, right? Except one's the opposite. So instead of having to take both of them, I think that we should just change one to be negative. So, see if you can follow this algebra here. What if I pull a negative out of this problem? So like if I pulled a negative out of this and moved a negative up there, that means I'm going to change this around because I'm going to pull a negative out. And so that's going to change that to sine of x minus cosine of x. And that negative right there allows me to do that. We do that in algebra 2 when we do rational functions. If we have one of them is 1 minus x and one of them is x minus 1, we pull a negative out. And so now, in order to make these balance, if this is my new denominator, they both have this. This one has a cosine, which means I need to multiply this side by sine. So that becomes sine cubed of x. This one has a sine, but it doesn't have a cosine. So that becomes minus cosine cubed x. This is where I wrote wow, frowny face on my paper, because I realized what I had in the top there. That is the difference of two cube numbers, which is the formula that I gave you at the end of the notes yesterday. So I factored that, a cubed minus b cubed. So that's going to factor into sine of x minus cosine of x times the first one squared, which is sine squared x, plus sine times cosine plus cosine squared. And again, how do I know that? Because of the formula. A cubed minus b cubed is a minus b times a squared plus ab plus b squared. So finally, after all those steps of common denominators after common denominator, we're finally getting to a point that's getting close to the answer. This is going to cancel out with this. And again, look what I have left in the top. I see my favorite sine squared plus cosine squared that I can add together. So that's going to become 1 plus sine x cosine x over cosine x sine x equals 1 plus secant x cosecant x. You see it? I call this undoing a common denominator. Notice here. That was probably really loud. I just dropped the microphone. Sorry about that. Here I have a fraction on this side. Here I don't have a fraction on this side. Mason asked me yesterday if you could switch and now switch and work with the other side and make it match that. You can, but you can also undo this denominator. This is addition, which means you could like break it apart as two fractions. You could say this is 1 over cosine x sine of x plus sine x cosine x over cosine x sine x. Right? Common denominator, you just break it apart with the plus sign. So look what I have. The sines canceled, the cosines canceled, that's plus 1. And 1 over cosine is secant, and 1 over sine is cosecant. And after maybe the worst proof ever, I think I'm calling it and saying that works. That's impressive, right? What I have for you today is a worksheet to kind of review this. All of the worksheet are proofs. Your quiz tomorrow is 4 proofs. We will definitely talk about some of this worksheet tomorrow. We will not do all of it tomorrow, but you should be able to do some of these, especially after doing your homework. Common denominator stuff, definitely do common denominator. I will tell you that on some of them, you might need to do like we did 16, meaning that you might need to multiply the top and the bottom by something. I'll tell you even right now, I know you don't have the worksheet, but number 4 is very similar to number 16 that we did in the homework yesterday, meaning that in order for me to do number 4, I multiply the top and the bottom by a trig function, or maybe 1 plus a trig function. You can do that on another one too, but maybe you don't have to, but I think number 4 and 5, I did that. More than one way to do these. Some of these do not have very many steps. Like I'm looking at my worksheet right now, I have a couple that only, like 3 of the 8 only have 2 steps for me. One of them only has 3 steps. But work on these. I've left notes with the sub that you're allowed to talk to each other. Definitely if you get stuck. I don't want you like putting your desks together because I know that's just going to create less work and more talking. But if you get stuck, definitely talk to someone, but try something. I think it kind of works out well that I'm not here because it makes you guys have to think and work through them. We will do a few of these together, but we'll also turn this in tomorrow. So don't come in here with a blank worksheet and think that you don't have to turn it in. Also, we have a quiz tomorrow. All right, it is a senior breakfast tomorrow, so I will be down at the senior breakfast, not in my room in the morning. Okay.